In this podcast, we are going to talk about ketones, not only how to name them, but also how to draw them. So when identifying if you have a ketone, you're looking for a carbonyl that is in the middle of a chain. So these could be carbons any length long, but they could be different, they could be the same, but you're looking for a carbonyl wedged between two R groups. Okay. We are going to talk about how to name using IUPAC conventions and how to name using common naming systems, and we're going to start with IUPAC. In IUPAC, you are going to number your chain, giving the carbonyl the lowest number possible, and no matter which way I count, that carbonyl is going to be in position number 3. So I'm going to state where that carbonyl is, and we number and identify where the carbonyl is if there are 5 carbons or more. In other words, if it can be any other place than where it is, then you have to number it to identify it. My parent chain is 5 carbons long, so that's a pentane. And for ketones, we change the ending to pentanone instead of pentane, so we add that O-N-E ending. To use the common naming system, we'll work this a little bit different. So I'm going to isolate my carbonyl, and I'm going to identify the groups that are on either side of my carbonyl. So on this side, I have an ethyl, 2 carbons long, and on this side, I have an ethyl. So the way I would name this is diethyl ketone. If the groups were different, I would if say it was an ethyl group and a methyl group, I would alphabetize those. So ethyl methyl ketone. But because they're the same, I can use diethyl for that for the common naming scheme. All right, our next structure we're going to draw is 5-chloro-3-hexanone. So I want to pay close attention to the parent chain, which is 6 carbons long. And ON tells us we have a carbonyl in position number 3. So I'm just going to kind of space these guys out, 6 carbons long, 5, 6, and I'm going to count 1, 2, 3 is where I have my ketone. And coming off of the 5th chlorine, coming off the 5th carbon, I have a chlorine. And now I'm just going to fill in H's. So I have 3 bonds here, we'll need 1 H. Only 2 bonds, we'll need 2 H's. This carbon's full with 4 bonds, 2 bonds here, and 3 hydrogens there. Okay, so here we have 5-chloro-3-hexanone. All right, we're going to have to name the structure, so I'm going to look for that functional group. That carbonyl is attached to a cyclohexane. So I'm going to start with the parent chain, cyclo, and I'm going to change hexane to hexanone, because it is a ketone. Then I can deal with this functional group. Your ketone always gets position number 1, so I'm going to count 1, 2, 3, 4. So my methyl is coming off of my 4th carbon. So this is 4-methyl cyclohexanone. Okay, so we have saved kind of a tricky ketone for the last one, and that is acetone. Acetone technically has 3 different names. Acetone is a ketone that has 3 carbons with the ketone in the center. So this is what it looks like. Something to keep in mind with acetone is that its IUPAC name is not actually acetone. Its IUPAC name is derived from the parent chain, which is 3 carbons long. So that would be propane, but we changed the ending to propanone. Whoops. Propanone. We don't have to say where the ketone is because it has only one option. It can only be in that middle, or it wouldn't be a ketone. If we were to name this using the common naming system, we would look at each of the functional groups coming off of the carbonyl, so we don't count that carbon. So in this case, we have 2 methyl groups coming off of our carbonyl, so we would call this dimethyl ketone.